Thank you all for joining, and I'd like to hand over the webinar platform to Pam Buffington, who will be moderating the session today. And Pam is the co-facilitator of the Northeast Rural Districts Research Alliance. And good afternoon, Pam.
Thank you, Peter. Very nice introduction. And as Peter mentioned, this particular webinar is focusing on using online courses to expand access to Algebra I. So we'll be talking about two recent experimental studies. We also encourage you to ask additional questions that are relative to providing access to both coursework and professional development through technology, as the Rural Research Alliance that Peter mentioned will be focusing on some of these topics over the next 5 years. As you see here in front of you, Peter briefly explained what would be available to you within the Adobe Connect. In part number 3, that's where you can enter information in the chat, and I encourage you to enter your questions. We do have some opportunities to stop and take questions and answers, and one of our researchers here will be keeping an eye on that, and we'll try to pose those questions to both the researchers and to the other staff here as we go along. What I would like to do first is to just give you a sense of the agenda. As Peter pointed out, we will start with introductions. I'll give a little background to the Northeast Rural Districts Research Alliance, what the structure and goals of that is. Then I will hand it over to Jessica Heppen to talk about the Access to Online Algebra study, and then to Dr. Kirk Walters to talk about the Back to Track study. Then we'll have an opportunity after those two presentations have been made to have a discussion about both these studies and then the broader context for this work. I want to first start by introducing Dr. Jessica Heppen. She works on the REL in REL NE as a researcher and works at AIR as a research analyst. Her colleague Kirk Walters also works on the REL NE as well as working at AIR. He is a colleague of mine on the Rural Research Alliance, as is Haruna Ba, based in our EDC office in New York City. Additionally, Dr. Peggy Clements works for Education Development Center and is a researcher within the REL system, and she was co-principal investigator on the algebra study that Jessica will be presenting. Both Dr. Heppen I'm going to start by just talking a little bit about the introduction while he was in the lobby. This particular REL contract really focuses on bringing the research needs of practitioners to researchers, and we are working within an alliance structure to better integrate what your understanding of the needs are with what we can investigate as researchers. We're really focused on learning from practitioners and continuing a body of work across 5 years. Most of the REL resources are focused on these research alliances. If you've been involved with the RELs in the past, you know that we also do need sensing and responding over time to the needs of folks, and we're trying to do this in very cohesive, coherent ways in this particular contract. We're really looking forward to this work. This particular bridge event is coming out of the Northeast Rural Districts Research Alliance. The goal for our alliance is to bring together rural education stakeholders in the region to create a shared research agenda that will ultimately provide research support for rural schools and districts. As you can see here, 3 areas that have been identified is around supporting student success and meeting the Common Core state standards, understanding and building local capacity to understand data related to programs and initiatives. As I saw folks logging on, I noticed there are people across the region. I saw folks from Maine, New Hampshire, Vermont, New York, and others, and I want to encourage you to be in touch as if you're interested in these issues, because we'll continue to reach out to have additional participating members of these alliances. I also noticed there are folks as far away as South Carolina and other places, and we encourage you, as Peter said, to stay connected to our work through the REL website. Of particular interest, as it connects to this webinar, folks within the Northeast Rural Districts Research Alliance are interested about access to programs that help prepare students to be college and career ready. There has been in particular a focus around the science, technology, engineering, and mathematics topics. How can we this particular webinar gets to providing access to courses when we are in those situations, although as our researchers will explain to you, the study was done in both rural and some other size and profile schools. So I'm going to pass this over to Jessica. The goals for this event is to describe the design and results of these studies and provide opportunities for you to ask questions. So as I said, I encourage you to type in the chat and provide questions throughout. We'll stop and take opportunities to answer those questions. We're going to start by getting a sense of where you are at. Do you use online courses, and if so, for what purposes? So I'm going to start with the first poll. The first poll question is going to ask, does your school or district currently provide online course offerings for students? So if we can bring that poll in. As you can see here, the poll is in front of you. If you would just click on yes or no. As you are entering those, we're going to broadcast the results so we can see how many folks on this webinar are currently offering online courses for students. With 14 people responding to this point, we have 71% are, in fact, offering online courses, where 28% are not. I'm going to give you just another minute. We have a few more people responding. Quite interesting that we have about, right now, 2/3 and a third. So thank you very much for that particular poll. It gives us a sense of those of you that are online. The second poll is going to be, if you do in fact offer online offerings, what areas do you offer those in? We have for choices here AP, credit recovery, online for existing courses, and enrichment. With that in mind, be aware that you can check more than one of these options if you do more than one. Noticing that there is actually quite a spread where folks are just about equally offering courses for a variety of reasons, with between 2/3 and 80% or so of each of these offerings. That's really great. Thank you for that information. And then our final poll is going to be, does your school or district currently provide online professional development for staff? Of those responding at this point, it looks like about 2/3 2/3 of you do, in fact, provide online professional development for staff, and a third do not. Once again, thank you for your input, and you can provide more context in the chat as well. And now I'm going to turn it over to Jess, who has a better sense of the context that she's speaking to in terms of what you're currently doing. Jessica? Is Jessica there? Well, while Jessica is getting back on the line, I will actually provide an opportunity. Peggy, are you on the line?
Yeah, I am on the line. I don't have control of the slides, but if you want to back them up to the first slide, I can certainly start talking about the study.
Yep, here we are.
Okay, great. All right, so what we're going to do right now is present the findings of a study that we conducted as part of the Regional Education Laboratory Northeast Islands. The study was published in December. And before we get started, just let everybody know a heads up about what the key findings are. So what we found was for students considered eligible for Algebra I in the 8th grade, if they had access to taking an online Algebra I course, it both positively affected their algebra achievement and doubled their chances of participating in an advanced math course-taking sequence in high school. And so the participating schools in this study were all middle grade schools in Vermont and Maine that had students who were academically ready, had at least some students who were academically ready to take Algebra I, but did not offer Algebra I to their students. And there were a variety of reasons why they weren't able to do this. In many cases, just a few students were ready to take the course, and it wasn't quite enough to offer a full course, or maybe there wasn't a teacher who was qualified to teach online Algebra I. But for a variety of reasons, these schools didn't offer a full Algebra I course for their 8th graders. So in addition to finding that there were really important positive impacts on kids' algebra outcomes, we also found that there weren't any negative consequences. It looks like Jessica's back, and so I'm going to hand it back over to her.
Okay, thank you, Peggy. Thanks for covering while we dropped off. I'm not sure what happened with the phone line, but of course, do flag us down if you lose us again. I'm not sure what of the introduction was heard or not heard, but again, I'm Jessica Heppen from AIR, and I'm presenting on behalf of a study team that includes Kirk Walters, who's already been introduced, and Peggy Clements, who you've already met. And thank you again, Peggy. Other members of the study team are Anne-Marie Faria, Cheryl Toby, Nick Sorensen, and Katie Culp. Peggy was just going through the key findings. We wanted to present this first because, of course, the study, the Access to Online Algebra study was was published in December 2011, and so you may have already seen the report or seen reports about the report. So just as a frame for the presentation, we wanted to give you a sense up front of what we found and then dive into the details of how we went about the study. Peggy went through the key findings, I think, on this slide. Thanks again. And to say, the overall finding of this study was that offering Algebra I as an online course, which, as you all indicated in the polls before, not the specific courses that you're offering, whether it's Algebra I or something else, but obviously there's a lot of implementation of online courses in K-12 education, increasingly so every year. And we found that doing this in this context is an effective way to broaden access in schools, to make the course more available to 8th grade students who are eligible for the course. Okay, so just to go over what I'm going to present in this section of the presentation, we'll go over the rationale and the background, the context for the study, tell you about the research questions that we posed and who participated, the design of the study and who participated. we're going to talk about math instruction in study schools, including the implementation of the online course, which we're sure that for those of you that haven't had a chance to read the report, we'll have a lot of questions about, so we'll spend some time there. I'll quickly go over the results in more detail than that key findings slide that you just saw, and we'll talk about the conclusions and the implications leading to a discussion about the findings. So background for this study. Though, of course, Algebra I is widely considered and has been for a long time to be a gateway course, some schools don't offer it to 8th grade students, and there are a host of reasons why some middle schools don't offer Algebra I to 8th graders, given the policy impetus that has occurred over the past few decades to really push, if you will, Algebra I down to the middle school level. Schools that don't offer Algebra I to 8th graders are often small and in rural areas, but of course not always. And in these schools, of course, some 8th graders are considered academically ready for Algebra I, but there may in these schools be too few of these students to form a full section of Algebra I. Or there may not be a teacher who can work it out with their schedule or who has the content knowledge to teach Algebra I in 8th grade. Nationally, we think, based on analyses of nationally representative data, that about 25% of high-achieving students, so these are students who we would think would be eligible for Algebra I in middle school based on their prior achievement, were not enrolled in a formal Algebra I course in 8th grade. And in rural schools, the figure is 39%, so significantly higher than in urban and suburban schools, the percentage of high-achieving students that don't take Algebra I in 8th grade. At the school level, nationwide, about 16% of schools don't offer Algebra I to 8th graders, again, for various reasons. And among rural schools, 24% don't offer the course. That's in contrast to 21% of urban schools and about 9% of suburban schools. So in schools that don't offer Algebra I to 8th grader, again, disproportionately rural schools and rural students who are academically ready for the course in 8th grade wouldn't take a formal Algebra I course until they get to high school. And often they're feeding into regional high schools. Those of you in rural contexts are very familiar with this scenario, with other students who may have similar academic backgrounds as far as achievement goes, who did have access to Algebra I in 8th grade. I just want to be really clear about what it meant to not offer Algebra I to 8th graders. So when we talk about the percentages of schools, for example, that don't offer Algebra I, what does that mean? We knew going into this study, we knew at the outset that students, especially these academically ready students, did access Algebra I in a variety of ways that didn't represent full access to the course for all students considered ready. We knew that some of these students go to the high school for Algebra I when their schedule allows, when transportation could be arranged. We knew that, the historical age-old situation that there would be students sitting in the back of the class with an Algebra I textbook while the rest of the 8th graders took a more general 8th grade mathematics class. We knew that algebra, as the content of algebra, was integrated into the 8th grade math class, whether it was called general math or not. We knew that these schools, often schools that didn't offer Algebra I to 8th graders, were committed to heterogeneous groupings of students and having students with mixed ability levels in the same class with differentiated instruction. And we knew that some of the schools did offer the course to some, but not to all of their algebra-ready students, so that the access to students considered ready was limited. And all of these situations were considered places where broadening access to a formal Algebra I course could potentially benefit some students. So, of course, enter the online course. The appeal of online courses is clear. With continual increases in technology infrastructure and schools, broadband, everything, online courses provide schools a chance, as you all well know, to expand their course offerings without necessarily the need to hire additional teachers or find additional space. Offering online courses is a strategy that schools use to expand curricula seen in the news and in research studies in the last few years. No rigorous evidence prior to this study existed about their effectiveness on student outcomes. So underlying this study, and we have specific research questions, and I'll go over them quickly in a minute, but underlying the study is truly a policy question that asks, in schools that don't typically offer Algebra 1 to 8th graders or where access is limited, is it beneficial to offer Algebra 1 as an online course? Is this a good thing for students and for schools? And to be specific, where we're talking about benefits in terms of student math achievement and the courses that they subsequently take in high school, and where online Algebra 1 is delivered to those 8th graders who are considered algebra ready. So we're not talking about, in this study, broadening access to students who aren't considered academically ready using online courses. So our specific research questions focused for primary questions on the direct effects of Algebra 1 on these algebra-ready students. And I'll define what that means a little bit in a few slides. But the primary research questions asked about direct effects on end of 8th grade algebra achievement and the likelihood of participating in an advanced course sequence in high school. And we can talk some more about how we define those. And as you saw in the upfront slide, the punchline slide, or the key findings portion, we did find significant positive direct effects of online Algebra 1 on these outcomes. We also looked at some secondary effects, and the reasons why were that the adoption of the online course, we knew, introduced other changes in math instruction in schools such as the ones that I've described. We knew that a teacher, the online teacher, would be added to the mix of adults involved in math instruction. We knew that offering online Algebra 1 in schools that don't typically offer full access, where algebra-ready students may be integrated from the general 8th grade math class, right? So effectively introducing tracking in schools where it didn't occur in that way. And that therefore, would reduce the class size of the general 8th grade math class, making it more homogeneous in ability. So we knew that there could be a number of potential positive effects, side effects, if you will, or negative consequences of adopting or offering an online Algebra 1 course in these schools. And we thought that these questions were really important, and the schools that participated in the study, which I'll describe in a minute, also agreed that these were important questions to pose. So we looked at potential unintended consequences on the algebra-ready students' general math achievement. So instead of taking a general math course, in most cases, they were taking an Algebra 1 course. And so an important question is whether they lose ground in their general mathematics knowledge, achievement, and their skills. We also looked at potential unintended consequences on non-algebra ready students. These were the other students in the schools who weren't identified ahead of time as algebra ready or eligible for an Algebra 1 course. Were there any unintended consequences on these students who remain in the general 8th grade math class? And we looked at their algebra achievement and general math achievement at the end of 8th grade, as well as their planned or projected high school course taking. Okay, so how did we go about this? We randomly assigned a total of 68 schools in Maine and Vermont. They were cross states, into one of two groups. The treatment schools received the online Algebra 1 course during the 2008-2009 school year to offer to their algebra-ready 8th graders. And the non-algebra-ready 8th graders, who were the other 8th grade students in the school, took the regular math class. Control schools offered their business-as-usual math during 2008-2009 to both algebra-ready and non-algebra-ready 8th graders. Just so you know, the control group schools then received the online Algebra 1 course during the 2009-2010 school year. So the deal for participating schools was free access to the online course for students they considered ready for 2 consecutive years. So the control schools were just lagged by 1 year. So prior to random assignment, before schools ended up in either the treatment group or the control group, before they knew whether they were offering the course that year, 2008-2009, or not, all schools identified their algebra-ready students. And when they did this, they identified about 22% of their total 8th grade student population, which is pretty consistent with what we expected to see, and pretty consistent, actually, with the percent of students in the region and nationwide that take algebra in 8th grade. And again, the rest of the 8th graders in the school made up the non-algebra ready student sample. And these two groups, as I'll show you in the next slide with a figure, represent distinct student samples. So we never compare the Algebra Ready to the non-Algebra Ready students, and the non-Algebra Ready students aren't offered the online Algebra I course. So you'll see that in the next slide. So what you see on this screen is a figure representing treatment schools on the left and control schools on the right, where the treatment schools and the control schools include 8th grade students, some of whom are Algebra Ready and some of whom were non-Algebra Ready. And again, the percent across schools of Algebra Ready students was about 22%. In treatment schools, Algebra Ready students were offered the opportunity to take Algebra I as an online course. And in control schools, Algebra Ready students, like non-Algebra Ready students, took the business as usual math class that was available to them. In treatment schools, non-Algebra Ready students took the general 8th grade math class. So for our analysis, in order to determine the impact of offering online Algebra I to Algebra Ready students, we compared Algebra Ready students in treatment schools to Algebra Ready students in control schools. And then to get a sense of those potential negative consequences, whether there were any impacts on non-Algebra Ready students who, again, were doing their normal thing, but in treatment schools, they were doing their normal thing slightly differently because the online algebra course was being offered to some of their higher achieving peers. We compared those students in treatment and control schools. Our school sample, as I said, had 68 schools. They were fantastic research partners through the course of the study. Their commitment to the study was strong and consistent. There were 50 of them in Maine and 18 schools in Vermont. Most of the schools, 61 out of the 68, were classified as rural. And I often refer to them as middle schools. I'm getting better about this over time because more than 3/4 of them were actually K-8s or pre-K through 8 schools. Many of the schools were really, really small. The average number of 8th graders in the schools was 32, and over half of the schools had fewer than 17 8th grade students. We did have about 10 schools that were larger, that had 100 or more 8th grade students, but many of the schools were really, really tiny, and some had 1 8th grader, and many had 4 or fewer. The last bullet shows the student population as a whole, not just the 8th graders. On average, about half eligible for free and reduced price lunch, 95% white, 53% at or above proficient on the state math test in the prior year. So we had some economic diversity and diversity in some other student background characteristics, not much in terms of racial and ethnic minority diversity. Here are some descriptive information about the Algebra Ready and the non-Algebra Ready student samples. The Algebra Ready students, about 1/3 were eligible for free and reduced price lunch. You can see that a relatively small percentage were participating in special education programs or had limited English proficiency. Skipping to the second from the bottom row, you can see that the average grade 7 score, so this is their state assessment score on the mathematics test the year prior to the study, is 0.95. What that means, that's a standardized score because Maine and Vermont at the time used different assessments. That's a standardized score showing us that on average, the Algebra Ready students scored 1 standard deviation above the mean on the state assessment the year prior, which indicates that overall this student sample was relatively high achieving. And then if you move over 1 column under non-Algebra Ready students, you can see that some of the background characteristics are similar and some are different from the Algebra Ready students. The p-value column over on the far right gives you a sense of whether those are different. So the free and reduced price lunch eligibility was different. Special education eligibility was different. English proficiency, gender, racial, ethnic minority were not different. And then, again, that second from the bottom row shows you that, on average, the non-Algebra Ready students scored about 1/4 of a standard deviation below the mean on the state assessment from the year prior. So they were less high achieving than the Algebra Ready students. It was up to the schools to identify their Algebra Ready students, their eligible students. We didn't impose a criterion on this or a set of criteria, didn't administer an algebra readiness assessment. We left it up to the schools, and this was one of the many ways that we wanted this study to really emulate real life. And what these data suggest, as well as some others, is that even though, as I said before, we don't compare algebra ready to non-algebra ready students in terms of their outcomes, when we look at their background characteristics, we feel confident that schools did a reliable job of identifying their higher achieving students as eligible for online algebra. Just the last row of the table shows the sample sizes. We had about 445 algebra-ready students and just over 1,500 non-algebra-ready students. In parentheses, you see the number of students who were retained for analysis. In addition to schools having strong commitment to the study, we also had just incredible participation rates, both in using the online algebra course, but also in data collection, and had very, very high response rates in the study. The primary outcomes for the study, I mentioned them earlier: algebra achievement at the end of 8th grade and high school math course taking. The algebra-ready students we followed into their first year of high school. So when they left the middle school or the pre-K or the K through 8 school where they participated in the study and either took online algebra or not, depending on whether they were in a treatment or control school, we followed them into high school, found out which high schools they were attending, followed them into high school, and just collected at the end of 9th grade information about the math classes that they took in 9th grade, the grades that they earned, and then the classes that they planned to take in 10th grade. And we used all of that to code each student as participating in an advanced course sequence or not, which was defined as the successful completion of a course above Algebra 1. So in a traditional course sequence that goes Algebra 1, Geometry, Algebra 2, etc., it would be the completion of Geometry in 9th grade with a grade of C or higher, and enrollment in the next course in the sequence. In this case, it would be Algebra 2 for 10th grade. We can talk some more about the course-taking follow-up information later if we have some more time. Our secondary outcomes were general math achievement at the end of 8th grade, and then planned high school course taking, which was collected at the end of 8th grade and based on enrollments in 9th grade math classes, but not on the basis of follow-up at the end of 9th grade to confirm. We're going to pause there for clarifying questions if anybody has any about the background of the study or how we set this up. Again, as I said at the outset, or maybe you didn't hear me because we were disconnected, we're sure that you have a lot of questions about the online course itself and how it was implemented. I'm actually going to go over that next, again, on behalf of my esteemed colleagues who worked a lot with the implementation data. So if you have those, you might want to hold off just until we get through the next section. But again, happy
to know that a number of you actually posted some questions when you registered, and we will, as Jessica said, there is one question about the results of the study. Those will be presented in more detail, even in the second section here, and specifically what we looked at in terms of student gains and so on. So those questions will be answered. There are a couple of other questions for folks to actually respond. I do notice that Rama is live teacher and online. I'm going to start by having Dr. Clements respond. You can do so via the audio, Peggy, if you'd like, and then if you want to, I can hand it back over to Jessica or Kirk to answer as well. So Peggy, do you want to add more detail to your response?
In response to Rama's question, I actually replied to Rama. Let's let Jessica present about the implementation of the study and then see if she still has any questions, because I think it's a kind of a hard question to answer given how the study ended up, how the online course actually ended up being implemented. So I'm going to hold off for just a sec.
Okay, thanks, Peggy. I'm going to turn it back over to you, Jessica, then, but we will keep an eye on the questions and we'll keep responding. We'll have another pause in a few minutes. Jessica?
Sounds great. Thank you. Okay, so now I'm going to advance through the slides that talk about the implementation of the online course, and Rama will come back to your question, I think, as we go through. The intervention in this study was an asynchronous online Algebra 1 course offered to the Algebra Ready students in place of their school's regular 8th grade general mathematics course. So in the setup about the study, you may have wondered whether students in some cases took this course in addition to their regular 8th grade math class. And in all cases, we asked schools to make sure that the online Algebra I course was the math class for the 8th grade students that were participating. In terms of the logistical implementation of the course, there were things that Class.com, the online course provider, were asked to do, and there were things, again, that the schools, the treatment schools that were offering the course were asked to do. Class.com provided the online course platform, they provided the content, it's their course, and they provided the online teacher, who again was asynchronous, meaning that they weren't necessarily online at the same time as the students taking the course. The students were in their schools. They were formed into sections across schools. We had 10 total sections. And again, they were across schools, but there were no sections that spanned across states. The sections were formed mainly on the basis of scheduling. Schools were asked to provide space and a class period for students to take the course. And so some schools that were on block schedules and other schools that were on Monday through Thursday schedules were grouped together to form the course sections. Teacher-student communications occurred via messages sent through the online course learning management system. And so there were no emails in the communications. We'll talk some more about what we saw as far as communication went in a little while. Class.com provided both the online teachers and a supervising math specialist. They provided training workshops for the online teachers and also for the proctors, and I'll talk about them in a second. And they provided the course content and hosted it on their servers throughout, and there were very few glitches as far as this went. The logistic implementation went well. One of the roles that treatment schools were asked to fill was an on-site proctor. This was required for all students who were taking the course, was to have access while they were accessing the course to a real live staff person at the school who could support them. And we'll talk a little bit later about who the proctors were and what they did. Treatment schools were asked to provide access to a computer for all students taking the course with high-speed internet access, and as I said, a regular class period, a time and a place for students to take the course. The course is structured into units, topics, and lessons. You can see the units for Algebra 1B, which is the first half of the course, and Algebra 1A, sorry, which is the first half of the course, and 1B, which is the second half of the course on this slide. The course is a fairly traditional course in terms of algebra content and is very consistent to widely used textbooks in the states that we checked as we were looking at the alignment of the course with other Algebra I courses being offered in these states. So there are a total of 9 units, and a little later I'll talk about course completion for students who took the course in terms of completion of these units. So I'm just going to give show some screenshots to illustrate some of the online course features. The course was text-heavy, as most or many online courses are, with a look and feel like an electronic textbook, essentially, with some interactive features and embedded formative and summative assessments on which students got immediate feedback. So here you see some course content on slope-intercept, which happens to be, if you look at the gray tab in the middle of the screenshot, Unit 1, Lesson 3, Topic 2. And students can click on the hyperlink terms to get more information and definitions, so it's somewhat scaffolded as far as the information they can get. They can also get text with audio support. For each topic, students typically encountered an average of 7 web pages of static and interactive text, 1 or more chalk talks, which I'll show in a minute, 1 or more interactive activities, and an average of 8 what are called your turn problems and 10 practice set problems. So there was a fair amount of activity in the course, some of it interactive, as they went through the topics and the lessons. Topics conclude with a summary of key ideas presented and practiced during the topic set. Those of you familiar with similar online courses will, I think, find these familiar as well. Here's an example of a practice problem set on which students, they would enter their answers into the boxes, and then they would get immediate feedback about whether correct or incorrect with those check marks or the X's. And then they can also click Please Explain to get more information. Here's an example of the Chalk Talks that I mentioned on a previous slide. These were videos, and they were an example of one of the interactive features that online teachers use to provide instruction. They were recorded and then embedded into the course content, and students could go back and watch them when they wanted. And then the final screenshot shows an example of the Your Turn exercises. These were another interactive practice exercise used in the course. And in this case, the exercise was used to give students a hands-on experience with plotting coordinates. So they could use their mouse to draw on the, or to click and draw on the screen. Okay, so I'm now going to give you a sense of what the online teachers and the proctors did in their roles, as promised, when they were implementing the online course. Observing an online class is, of course, different from observing face-to-face classes. So what we did, and to be clear, this work was led by Peggy, who you've heard from, and Cheryl Toby and her team at EDC based in Maine, was observe the online course using archived online course data. So specifically, we took 8 24-hour snapshots per online course section throughout the year. And so with 10 sections I mentioned earlier, we had 10 across the 35 treatment schools. We had a total of 80 observations. So 8 observations for each of 10 sections makes a total of 80 observations. And so the information on this slide and the next slide is based on data summarized from those observations. So what you see about online teacher practices here is a statement about the expectation for online teachers. They were expected to log into the course daily and to monitor student progress and communicate with students regularly. On the right side, in the right box, you see what we saw in actual reality in terms of monitoring of student progress. So when we looked at the observations of based on the snapshots from the archived data, we saw that in 96% of the observations, teachers logged into the course, nearly 100% of the time. They monitored student login activities in 70% of the observations. And in only 43% of the observations could we see evidence that they had examined student grades. In terms of communicating with students, we use the same observation data from the online course system to see that online teachers send at least one message to an individual student in 91% of the observations. Of these messages, we categorize these messages into whether they were administrative or about math content or other. Administrative messages were observed in about half of the observations, and these involved 13% of the students. So when online teachers were messaging students, a relatively small percentage of students were getting those one-on-one messages. And in about half of the time, they were about administrative details. These aren't messages, to be clear, that went to the whole class that may or may not have been about math content. These were individual messages to students through the learning management system. Math content messages were observed in 13% of the observations, and they involved only 3% of the students. So one-on-one communication between online teachers and students through the online learning management system were relatively scarce in the implementation of this course. Students could also send messages to the teachers, by the way. So what did the on-site proctors do? And this gets somewhat to Rama's question from earlier. As part of measuring online course implementation, we asked the proctors to complete weekly logs to report the time they spent doing various activities in their role. So what was their role? So the proctors were responsible for making sure students had access to technology. They were responsible for supervising student behavior, proctoring exams, and serving as a liaison between the online teacher and the school and parents and students. They weren't required, as you can see on this slide, to be a math teacher or to provide math instruction. We didn't require that of schools because, of course, these were schools who, one of the reasons that they don't offer Algebra I typically may be because they don't have a math teacher who has the time available to do so. So we certainly didn't want to require that of schools. What we actually saw will show up on the right here. In 80% of the schools, the proctor was, in fact, the grade 8 math teacher. And in most of the schools, students sat in the 8th grade math class while they were accessing the online course. So earlier when I mentioned that scenario of students sitting in the back of the class with the Algebra I textbook, this looked a little bit like that, updated for current times, 2008, 2009 at least, with their laptops. Proctors spend an average, this is based on Proctor log data, of approximately 50 minutes per week answering students' algebra-related questions. So putting together what we know from the messages between online teachers and students and what we see reported from the proctors about what they did, students who took the online algebra course, in many cases, not in all cases, but in many cases, did turn to their proctors for instructional support, and the proctors were willing to provide it. So earlier I showed the 9 units of the course. Now I want to give you a sense of what course completion looked like, what we know about the content of the course. Now that we've moved on from what the online teachers did as far as instruction and what the proctors did as far as instruction went, 43% of the Algebra Ready students in treatment schools completed the entire course, all 9 units of Algebra 1A or 1B. Nearly 90% completed more than half the course, Algebra 1A plus some. And the average number of units that was completed was 7.5. So out of 9, that's 83% of the course on average. It's interesting to look at course completion for an online course because you have we had, and you have, if you do the same, such precise data at the student level for the number of units completed. And so we can really calculate this to a great degree of accuracy. What we don't know in a typical implementation of Algebra I, whether in 8th grade or 9th grade or in another grade, the equivalent of these units. We did look at math instruction in the face-to-face classes, both for the non-Algebra Ready students in treatment schools and, as you'll see on the next slide, for both Algebra Ready and non-Algebra Ready students in control schools. And so what we did was we collected all kinds of, and Kirk led this work, all kinds of classroom materials, including course syllabi and annotated textbook tables of contents. And we coded all of that information to indicate the percent of the content of the general 8th grade math class that was primarily focused on algebraic concepts. And so what we found across the board was that in most schools, about 80% of treatment schools, the general 8th grade math class, again, this is the class from which the online algebra students have been, I'll put removed in quotes because we know in a lot of schools they were sitting in the same room. But the content taught to the non-algebra ready students in the general math class emphasized algebraic concepts 50% of the time or more. So even this general math class with the algebra ready students removed was pretty heavy on algebra content. And then in control schools, similarly, we found that over 90% of the schools' general 8th grade math curricula emphasized algebraic concepts 50% of the time or more. So again, these general 8th grade math classes had a lot of algebraic content. This was the contrast for this study. It was certainly not online Algebra I versus no algebra. It was algebra in multiple different kinds of ways, both integrated into the general 8th grade math class in a big way. And as you see in the next bullet, a fair share of the Algebra Ready students in control schools actually took a separate formal Algebra I course. About 20%, so 1 in 5 of those students did that when we collected information about the math classes that they were taking and the content that they were covering in their 8th grade math class. Back when I said at the outset of the study, we knew that some of the students went to the high school for Algebra I, or in some schools they made it work with some but not all of the students. We certainly expected a small percentage of students in control schools to take a formal Algebra I course. Did we expect to see 20%? No. I mean, I think we would say that we didn't expect to see it that high. So again, this slide really shows you the contrast to which Algebra Ready students in treatment schools who took an online Algebra I course were compared. So when we think about the results, and now I'll go through those in more detail, again, you know that the effects were positive. Again, it's not online Algebra 1 versus no algebra. It's online Algebra 1 versus limited access to a formal Algebra 1 course and a whole lot of algebraic content. We administered a post-test to measure algebra achievement at the end of 8th grade. It was a computer adaptive test that was scaled from 400 to 500. And so you see the scores on average for the algebra-ready students in treatment schools and those in control schools on this slide. The difference between the scores, 447 versus about 441 and a half, was statistically significant. And though the bars using this scale don't look that different as far as their height goes, this translates into an effect size of 0.40, which means, 4/10 of a standard deviation move from the average, which is quite statistically significant and educationally meaningful. The next slide shows the results of our course-taking analysis. It shows that algebra-ready students from treatment schools, when they went to high school, had about a 51% chance of participating in advanced courses versus a 26% chance for algebra-ready students from control schools. And this means that algebra-ready students from treatment schools were really nearly twice as likely to participate in an advanced course sequence as algebra-ready students from control schools. Of course, a 51% chance is not a 100% chance. So there's a significant share of the students who had taken online Algebra 1 didn't necessarily jump right into an advanced course sequence. Some of them went to high school and they took Algebra 1 in 9th grade. But more of them than would be expected in absence of the online algebra course started high school at geometry or the equivalent, depending on the course sequence appropriate for that high school, and they were ready to go on an advanced course track. So summary of results, algebra-ready students with access to online Algebra 1, as you've seen and as you've heard, outperformed their counterparts in control schools on the end-of-year assessment, and they were more likely to follow an advanced course sequence in high school. It opened up doors for them that otherwise aren't closed until they get to high school. We also found no unintended side effects on algebra-ready students' end-of-year general math achievement or on any of the non-algebra-ready student outcomes. We don't have time today to go through those results. But what we found were no statistically significant differences on any of the outcomes that we looked at for those questions about side effects, and so we were really pleased about that. Speaking of leveling the playing field and opening doors, using the online course to open doors, there's just one more result that we wanted to share with you, that we did want to share with you today. About high school course taking. When we think about the pathways that students take to an advanced course sequence, as I mentioned, a lot of the students who attend schools that didn't typically offer Algebra 1 go to regional high schools with students who did have that opportunity in 8th grade. And so some of them, especially the motivated students, find ways of catching up. One of the phenomena that we heard a lot about when we were talking to schools about participating in this study, and that some of you may be very familiar with in your own schools and districts and region, is that students do find ways of catching up. And one of the ways that they do this is by taking two full-year math classes in the same year. So in addition to the main analyses that we looked at about whether students were taking advanced courses in high school, we also looked at the ways that they were, and we saw, even in our own data, very quickly as we were collecting the data from the high schools, that students were taking multiple year-long math classes within the same year. We did find an impact of having access to online algebra in 8th grade on the likelihood that students would double up in high school. So we call that phenomenon doubling up, of course. Algebra-ready kids from control schools had a 23% chance of doubling up. They're the bar that's shown on the right. So when they go to high school, assuming that they had limited access to Algebra 1 in 8th grade, they have a 23% chance of doubling up in high school versus a 10% chance for algebra-ready kids from treatment schools. This, too, is a statistically significant difference and suggests that one of the ways that online algebra had an impact on course taking was by reducing the likelihood that students would double up or would feel the need to double up in high school. So skipping for real, I was just joking a second ago, to the overall summary of findings, the study provides the first evidence at all that online Algebra I could be offered to 8th graders. So it was logistically feasible to do this. This evidence didn't otherwise exist in any formal way. You all have probably seen some examples of online courses being used at all different grade levels. Online teachers were less communicative than we expected to see. We talked about that. And on-site proctors gave more content support than we expected to see, and certainly than we required. Less than half of the students completed the whole course, but almost all the students made their way through the first half and some of the second half. And their counterparts in control schools were exposed, again, to substantial amounts of algebra, and fully 1 in 5 took Algebra I. So our conclusions based on the findings are that the online course, as it was implemented in this study, and Kirk is going to talk when we move to the next study about a totally different use of online Algebra I, but in this case, as implemented, promoted student success in mathematics compared to what business as usual in these schools. And so we conclude that using an online course, again, is and later to a more challenging set of opportunities, and not just that they take more challenging courses, but again, the way that they do this. A longer study, of course, is needed to see whether and when these pathways converge and whether the benefits of online algebra in middle school, access to online algebra in middle school, persist over time. But again, we're really encouraged by these findings, and we think that there's a lot of promise, and there are some real concrete takeaways for educators in the region and around the country from this study. So I think we're ready to move on from here to a discussion. I'm going to pass it back to Pam for questions that arise from you all in the chat and that were posed earlier.
Thanks, Jess. One of the questions that were posted online, I'm noticing that there have been a couple of questions. Thank you, Amy and Rama, for posting those, and Peggy has responded to those. There was a question that was posted on registration where they asked what common pitfalls that can be avoided in using online courses to expand access. I know you can't talk generally, but as it applies to this study, as you were collecting data and actually doing field observations, were there some things that you noticed? And I'll turn this over first to Peggy to talk in terms of implementation, and then maybe you just can answer that more generally. Peggy, do you have any thoughts about common pitfalls that could be avoided?
Yes, I mean, definitely in terms of this particular study, we know that in the first year, Jessica mentioned that in the first year, the study year, the online course was offered obviously to the treatment schools, and then in the second year, it was opened up to the control schools, and so we had the opportunity to see how the online course provider provided training for the on-site proctors in both the first year and then after they'd had a year's experience of doing this. And one of the things they emphasized a little bit in the first year was the importance of having students develop, print out a pacing chart, and for the on-site proctor to keep track of the pacing chart. And we know that in the second year, they emphasize that to a much greater extent, really pointing out the real need for students to have a pacing chart, and even to, have a notebook where they kept track of their work, so that the on-site proctor, even though he or she might not have been a mathematics instructor, they could see, that the student was engaged in, in answering the questions and moving forward. And even in some of the most recent work, excuse me, I've done now, when you hear people who are real advocates of online learning, you hear them speak about the fact that, if kids can do this successfully, they're going to need to learn how to, manage their time and pay attention to, what's, again, what the pacing of the course is and what needs to happen when, so that they can complete the course successfully. So pacing, keeping on pace is one of the biggest issues, I think, that can really trip kids up in terms of successfully completing an online course. Pass it over to Jess now.
Yes. Jess, do you have some thoughts on this question?
I think Peggy did a great job of covering that. I mean, when we think about the logistical aspects of the implementation, everything went really well. I mean, for the most part, and Peggy has all, details of all of this, but the computers worked well, and the technology worked well, and the internet worked well, and Class.com did what they needed to do to keep the platform up and running, and all of the preconditions were there. The real nuts and bolts of the implementation are in the content and in the instruction, and I agree that pacing was a concern for some and less of a concern for others, and in interesting ways, and even that can be further studied.
Thanks, Jess. One of the things that is being asked in the chat right now is about pacing, and I concur with what Peggy said around students keeping track of where they're at and what they've accomplished and so on through the use of notebooks. One of the observations that one of the math content coordinators and a district that implemented made was that the students that indeed participated in the online course were actually much better at keeping track of their own pace during regular in face-to-face courses, a lot better in terms of self-monitoring. So sometimes even the students shared that they were willing and more able to go back, replay videos, and reread things so that they were making those decisions themselves, and it seemed to make an impact as they moved on to high school. Another question I noticed in the chat is posed by Tom. Tom, we're actually going to talk a little bit more about that, and I'm going to turn it over to the researcher on the Northeast Rural Districts Research Alliance as we are proposing work in that area. Kirk, do you want to answer Tom's question at this point?
Of course. Yeah, it's a really good one. So for those of you that aren't familiar with the Connected Math programs, abbreviated CMP, it's actually the largest, it's the most widely used quote-unquote reform math program. It's more problem-based and conceptual, and the 8th grade CMP program actually has an awful lot of algebra in it. And his question had to do with taking CMP as your base, which is already pretty heavy in algebra. And by the way, the CMP was the most commonly used textbook in the virtual algebra, for access to online algebra study as well, which could explain why there was a lot of algebra going on in these general 8th grade classrooms. But, and then his question is, supplementing that with something like the Khan Academy, which some of you may be familiar with, which are more tutorials on different math topics, and some argue that it's called a flipped classroom, when kids would, instead of doing homework out of their textbook at night, watch one of these videos on, this could be an algebra topic, and then come back in class the next day and actually solve some problems. The argument there would be that the teacher would have more time during class to help kids when they're actually doing math. And this is really untested, kind of uncharted waters. But so two things. One is that our study doesn't offer too much direct evidence to answer that question. But one of the things that we're working on in this current REL contract is a research agenda that hopefully will. And we've worked on a proposal that will be submitted very soon to IES, where the purpose is to really find out what types of programs like Khan Academy, there are many others, some that target students, some that target teachers, that are accessible online and specifically designed to help teachers implement the Common Core. So I think we expect to learn a lot more about that, in the coming months, and that's information that we would, the whole point is to share it with people like you. So I think you probably know your staff best. If if CMP2 is implemented as designed, and that's a big if, but if it is, there's an awful lot of algebra there, and there have been a few reports, at least one that I know about, and I believe it was in North Carolina, and Tom, I can probably dig this up after the webinar and send it to you, in which the CMP students were compared with kids that took algebra, and they were comparable. Now, this is not, I'm not saying that it was a randomized trial like we did, but there might be some suggestive evidence that if it's implemented well, they're going to get a fair amount of algebra, and then you could see if supplementing it in the ways that you suggest would sort of flesh that out. So unfortunately, I can't give you a silver bullet answer, but hopefully more to come, in the coming months, and I'd be happy to follow up offline about that particular program too.
Thanks, Kirk. With that, if I don't see any more questions in the chat, I'm going to move on, but please feel free to continue to ask questions because we'll be pausing again after the next study is presented to answer questions as well. So Kirk will be talking about the Back on Track study. Kirk?
Okay. I feel like I should let everybody stretch, but since it's a webinar, you're probably already stretching. So this presentation will be a little shorter, quite a bit shorter, in part because it's a study that we've just started. There are some commonalities in that it involves an online algebra course, but it's targeted at a different group of students. And what I'm going to talk about in this presentation, I'm just going to describe the rationale for the study, talk a little bit about the online course, not as much as Jess mentioned about the class.com course, a little bit about the design and who's participating in the study, and some of our early findings. We're about 1 year into this 4-year study. We do have some early results that we think are relevant, but the full story will play out in the coming years. So the Back on Track study, just in terms of before I say why, I just want to say that it's a partnership between the American Institutes for Research, AIR, the Chicago Public Schools, and the Chicago Consortium on School Research based at the University of Chicago. And just like the Access to Online Algebra study, I mean, these things don't happen unless there are truly great partners. And the same has been true as this study as it was in the Access to Online Algebra study. I think that's one of the most satisfying things about doing research, field research like this, is that it feels like a true partnership. So that's just a little bit of background on there. So we are, in terms of why this study? Well, first, let me explain how it's a little different. Instead of targeting algebra-ready students in 8th grade that had been identified by their schools as probably having sufficient motivation and skills to complete an online course pretty much on their own, we decided to look at 9th graders who were not successful in Algebra I during the 9th grade year and are trying to get back on track toward graduation by taking a course. You might recall the slide where Jess presented Algebra 1A and 1B content in the class.com course. This study focuses on just the second half, or the 1B of algebra. And we know that in 9th grade, your credits in 9th grade are really strong predictors in terms of graduation. You don't want to wait. Among those courses in 9th grade, we know that algebra has the highest failure rate. And we also know that algebra is really the foundation for a series of college preparatory coursework and opportunities in the STEM areas. It's referred to as the gateway to a lot of these other opportunities. So for lots of reasons, algebra makes sense. It also makes sense in 9th grade because we know that in Chicago in particular, it's a pretty startling statistic, but only 13% of 9th graders in Chicago that are not successful in algebra, only 13% of those go on to graduate. So it's sort of a no-brainer in terms of where the needs are. in thinking about this study, we also thought, and I think there are probably some former algebra teachers on this webinar. I know Pam used to be one, and Cheryl on the team. We also thought kids that are more at risk, in the summer they're given the opportunity to focus just on that course for a period of time, and perhaps during the school year they were bombarded with 6 or 7 other courses and weren't able to focus on it. Perhaps that contributed to their not being successful. And we also know that online courses are just being used more widely for credit recovery purposes. So these are some of the rationales for the study. As I mentioned, it is a fast-growing credit recovery, and online credit recovery is fast-growing in K-12 education. One other sort of piece of information that went into our decision to focus on online for credit recovery is that the kids who weren't successful during the school year took it in a face-to-face environment. So perhaps the change in venue and mode could be better. We also know that the promise of online courses in terms of the ability to present content in a graphically rich way, it can be interactive, there can be immediate feedback, some of the things that Jess talked about in the implementation of the class.com course applies here. And yet we really don't know whether online courses are effective or not. So in this particular study, if you think of Jess's presentation and the access to Algebra I, to online algebra study, that was really giving an opportunity to kids to take the course who wouldn't have been able to otherwise. This particular study is looking at kids who weren't successful and comparing online versus face-to-face as a delivery mode. So this is the head-to-head comparison, if you will, whereas the previous study was access to versus not access to an online course. And that's an important thing to keep in mind, and they're different questions. So the intervention, the course that we're currently using in Chicago is not the class.com course. It's a course developed by Aventa Learning, which has since been purchased by K-12. I'd say on the average it's pretty similar to the class.com course in terms of being an electronic textbook, in terms of having an online teacher, in terms of having different types of activities and resources like Jess mentioned. They're not identical, but they're similar. There are opportunities for students to go at their own pace and to get ongoing feedback. The real reason we picked it is because Chicago has done over the past 5 or 6 years some piloting of different online programs for credit recovery. So this is something that they were keenly interested in, and they thought that the Aventa course sort of suited them best among the different providers. We focused on Algebra 1B versus Algebra 1A in part because there's a higher failure rate than Algebra 1A. The content gets progressively more difficult. You also could imagine a study where you focused on the whole course over a summer. We felt like it was more important to start with kids that were in need, especially of that course, although we do include kids in our sample that still need both the 1A and the 1B credits. But for those reasons, we focused on 1B. In terms of how the course was structured, like the access to online algebra study, kids actually came to the building. It took place in their local high schools, often in a computer lab. And like the previous study, kids had access to an online teacher, this time provided by Aventa, as well as an in-class mentor, which was the Proctors, the term we used. Proctor, mentor, the person who's in the building with the kids when they're on the computers. Kids go for 4 hours a day. That's pretty much, most of the time was when they showed up to school, when they were on the course. In terms of the design, this is also a random assignment design. However, we focused on the students. We randomly assigned students within each of the 15 schools that participated last year into either the online course provided by Aventa or the face-to-face course, which was taught by whomever the school decided whichever algebra teacher wanted to teach that summer. They had different criteria for picking which teachers, but the schools decided that. So I think that's good. We had, student level random assignment. I'm going to talk there's a later slide that talks about how that random assignment was sort of pulled off, which I'll get to in a minute. In terms of our research questions, the first question there, the first bullet, is what is the impact of taking online algebra for credit recovery compared to a standard face-to-face course? So here's the head-to-head question that we were really interested in. In terms of the outcomes that we're going to talk about today, what is the impact in terms of students' test scores and their pass rates? And we gave them a test at the end of summer school, an algebra test, as well as what's the impact on their longer-term achievement, course-taking patterns, and ultimately on-time graduation. We won't have time to talk about that now since we're only 1 year into the study, but we will at some point. We also were interested in the conditions in which the online and the face-to-face credit recovery courses are effective. And so some of the things that we talked about in the earlier presentation, what does it mean to take an online course? What is the role of the online teacher, the mentor, the proctor? A lot of that is really understudied, and so we're interested in collecting a rich source of implementation data as well as information from students, looking at students with different skill levels. We also survey the kids, and so we have a sense of their attitudes and dispositions and so forth. In terms of the schools, again, this is in Chicago, and last summer we had 15 schools participating. We're hoping to have at least that many, maybe a few more this summer. In terms of the characteristics, you can see that they were pretty disadvantaged in terms of free and reduced price lunch eligibility. Almost 9 out of 10 qualified, and that would be for the study schools as well as CPS as a whole. Maybe the other interesting slide is bar graph at the bottom of this chart. You notice the Algebra 1B failure rates. The study schools had 23% failure rates. They were higher than the 19% in the district. We targeted these schools because there was a need. So these are places where there are a lot of kids that stand to benefit from taking summer school, be it online or face-to-face, who are in need of credits. And as you might imagine, if you're going to do student-level random assignment at the schools, you want to go to places where there is a need. Otherwise, there's nobody to provide the support to. In terms of the random assignment and the way that happened was that we had researchers that were at the schools, deployed all around Chicago, and instead of randomly assigning the students prior to summer school, you might imagine that we could have looked at student records and the number of students that failed the second semester, for instance, and done the random assignment administratively, and then just assign the kids, as they show up, they've already been predetermined to be in the online or face-to-face class. Well, we didn't want to do that for several reasons. The primary reason is that the study is designed, once kids are randomly assigned, they stay there. And so we assumed there would be a lot of no-shows, especially given that with this at-risk population, it is often a challenge for a variety of reasons to get all of the kids who need the credits to actually attend on the first day of summer school. So we did the random assignment on site. And the average size per section, as you can see, about 16 students per section, 305 in the online, 287 in the face-to-face. And there were no significantly different baseline characteristics. When you look at those two groups, they were similar on all the characteristics you would want. In terms of the outcome measures, the short-term outcomes, we're just going to talk about this end-of-course assessment and their credit recovery rates. The longer-term outcomes, which is not the focus of the day, are achievement in the algebra achievement scores, the plan, ACT, course taking credits and grades, and dropout and graduation. So you'll have to come back in a few years, or we'll have to come back in a few years to talk about those. In terms of our implementation measures, we had surveys for students and teachers and the mentors. We also had weekly logs that the mentors completed describing their activities. We had observations of the classroom teachers as well as the computer labs where the mentors were. And we have a rich set of archival data that's generated by the event of course. In terms of the online teachers' background, the online teachers, so if you look at the chart right there, all of the online teachers and the face-to-face teachers were certified secondary math teachers, whereas the online mentors, those that were proctoring the course, did not have to be math teachers, and you can see about half of those were. In terms of advanced degrees, in terms of advanced degrees, you can see that the face-to-face teachers and the online mentors, about 80%, between 80 and 90% had advanced degrees, whereas the online teachers did not. None of the online teachers, although there were only 4. In terms of the teachers and mentors' teaching experience, you can see that the online teachers, on average, were less experienced, but there were only 4, so they had taught about 5 years. In total, about 5 years teaching math, whereas the face-to-face and the classroom mentors, on average, were more experienced, 13 and 14 years teaching in total, roughly, between 7 and 12 years teaching math, and between 5 and 9 years teaching algebra. Like I said, we did observe the online classes and the face-to-face classes in the summer, and sort of the main gist of that slide is that across our observations, by and large, the kids were engaged in their learning. We also had a sort of a cooperation and attentiveness, and the overwhelming majority of kids were there and engaged. We don't know the extent to which they were actively engaged, but they were on task taking algebra. In terms of the end of course assessment, these are some results here. So when you look at the face-to-face and the online student scores in the end of course assessment, those 2 vertical bars there are pretty similar. 277 versus 276 would be the scaled score. Those were not statistically different, and in terms of raw scores, that's about a 38% correct that the online and the face-to-face kids scored on their end-of-course algebra test, which was comprised of NAEP public release items that included both Algebra 1B, which was the focus, and Algebra 1A content, because we knew that some of the, because Algebra 1B builds on 1A in terms of the content, we wanted to have some of those items as well. So in terms of the credit recovery rates, about, on average, 58% of the kids who attended summer school, either in the online or the face-to-face setting, recovered their credits. And when you compare the online versus the face-to-face rate, 62% in the face-to-face class versus 56% in the online class, and that was not a significant difference. So they recovered the credits at roughly the same rate. Depending on whom you ask, 60% might be a really big number. Others might think it's a smaller number. We certainly know that there were a lot more students, which I'll get to this slide in a second, that attended summer school and attempted to recover the credits as a result of this study than would have otherwise.
And it includes the kids that dropped.
And it includes all of the kids that dropped as well in these percentages, which is important to remember. So what we did as we reviewed our first year data, implementation data, and the preliminary results, we also went back and said, well, let's look at the year prior to the study and calculate the credit recovery rates before the study was introduced. And as you can see, in 2010, about 12% of those ninth graders recovered their credits, whereas in 2011, after the study, that almost doubled to 23%. Our hope is that in 2012, if you're ever in Chicago, you might see us. We're hoping that that number is even higher this summer, and we have some other strategies where we're working with schools to try to bring in even more kids this summer than we did last summer. So I think there's a conclusion. In terms of what these, again, these are really early findings. We do know that the overall credit recovery rates online versus face-to-face combined nearly doubled from 2010 to 2011. And we also know that that right now the recovery rates, the test scores, and the engagement levels of the kids are comparable in the online and the face-to-face sections. And I think I'm going to, but I think the other conclusions are the big ones. So I think I'm back to Pam.
Yes, thank you very much, Kirk. That was a lot of information and very informative. I have noticed there's been a really active chat. Peggy is doing a great job answering folks as you were presenting as well. So I want to give folks a chance to type in any questions in the chat specific to the study that Kirk just presented. Any additional questions? This is always difficult, the teacher wait time. I don't see anybody typing any questions in right yet, so I do want to just pose a couple of questions to us to answer. One thing I noticed is Marianne talked a lot about proctors and what the qualifications for proctors were, those with content knowledge and so on. As Kirk presented in this last study, in the online algebra study, the online content teachers were in fact highly qualified teachers in mathematics. So there was a content expertise for the online teachers, and as Peggy pointed out, many of the proctors were in fact math teachers, but in some cases these were K-8 schools where there was not necessarily deep knowledge in algebra, and so not always were the proctors math content leaders or had that deeper content knowledge, and so there was in fact the opportunity to offer a more rigorous content course in that K-8 school than there might have been otherwise. I'm going to ask this question to the staff as well. Jessica, do you want to add any more detail to that question about the qualifications of the online teachers or the mentors or the proctors in the first study?
Yeah, I mean, just to agree really loudly and strongly with Marianne and with Peggy and her responses that, you know, we're really interested in the different qualities, whether we call them proctors or mentors, of the people who are there on site to provide support to the students, and whether that is very sort of logistical, technical support, and whether it includes content and instruction and starts to look more like somebody asked very early on, and maybe it was Marianne, I'm not sure, I apologize, I haven't scrolled up to the chat, but about blended learning and when are we moving from a fully online course to a hybrid or some kind of blended model, and what is the role of the person who is there in the classroom with the students. I think when we think about 8th graders, these more motivated or high-achieving 8th graders, they're still 8th graders. And when we think about our 9th graders in our Chicago study, they're as Kirk described, I mean, these are very at-risk kids, and their engagement in school, by and large, on average, is pretty low. And so the role of that person includes all kinds of things, not necessarily content and instruction, but we've seen a lot of that in both studies. So in the online access to online algebra study, students really looked at those proctors who happened to be the math teacher they would have had if they weren't taking the online course as a resource to them for math instruction, and that's of no surprise at all. And I think it would take, and Peggy and I have talked a lot about this, it would take a real shift in the way that students interact with their teachers to start looking at an online teacher that they don't see and may not be online at the same time, or may sometimes be as their teacher, as their primary resource for instruction. And so that shared responsibility for instruction, I think, is still being shaken out. And we just really share the interest in continuing to identify those and help identify, for lack of a better term, best practices. In the Chicago study, the practices of the mentors and the relationship between those practices and student outcomes in the online course was of great interest to the district and has really been built in as a key research question in the study. We're still collecting the data that we need in order to address that over time, but I think it is really key when we think in general about the effectiveness of online courses. We have to really define that role and think about how people are doing it in different ways and what different kinds of students need in different situations.
Thanks, Jessica. I also noticed that Rama has asked some additional questions, so I'm going to turn this over to Peggy. Peggy, do you want to respond to Rama's most recent comment?
I think Rama's comment is meant to be funny. Now all you folks need to do is a 50-year study to see how this really works out. And I'd actually like to take this opportunity to really point out the role that the RELs can play with educators and education policymakers in terms of conducting research on programs and policies that are being implemented at state and district levels. Without being specific, I know of a state right now that's just passed legislation that makes legal 2 full-time virtual schools. Now, that's a very different type of online learning than we've been talking about, but there's been a lot of debate in a Midwestern state. They've just passed legislation authorizing the creation of 2 full-time virtual schools. And when a state or a district makes a big policy shift like that, it actually provides a really important opportunity to conduct an evaluation of what happens. And that's where, the REL researchers or any researchers really can be instrumental. So, for example, if you are, in a district or state that was going to implement a big, some kind of big policy shift like this, there are ways that researchers can help you think about rolling out this particular policy in ways that will provide you yourself, or you in conjunction with a researcher, to really follow and see what happens in the short term and the long term. I mean, we were limited for the online algebra study. The contract to do the study ended when the kids were in the 10th grade, and so that's as far as we followed the kids. But, with the creation of these state longitudinal data systems, there is the potential to maybe not follow kids for 50 years, but certainly to follow kids throughout the course of their high school careers, and to the extent that we develop, pre-K-20 data systems to follow kids even into their post-secondary learning experiences. So that's what I wanted to say.
Thank you very much, Peggy. And I'm really pleased to see that the chat has started to get active. And I'm going to start by answering partially Amy's question, and then I'll turn it back to you, Peggy, as well. She's asking, was student feedback collected in either of these studies on how they felt about the online course? In the first study presented, I was also on the team that did classroom observations, and when interviewed, students were very quick to say that they really like the ability to be able to move on when they feel that they're secure on content. And they also talked about how much they enjoyed being able to look back, and they replayed some of the Chalk Talks, the videos that they had, as well as they know they read something, and they could go back and actually find that, as well as check their answers and get immediate feedback. some students did share that they felt isolated at times from their peers, while others didn't indicate that. So just from anecdotal evidence that we collected, some students were really feeling good about engaging in courses in this way, while others felt a little differently. But Peggy, could you add from your perceptions about student voices in this research?
Well, I can say we have collected some some data about this, but at this point, for a variety of reasons, haven't had the opportunity to conduct those analyses. I certainly think we're learning in terms of student feedback about their educational experiences generally. There's been some recent research that shows that how students review their teachers is actually really highly predictive of how effective teachers are. So I think there's reason to believe that asking students about their experiences is, can and could be a really important way to find out how well this is working. But I actually Pam's right. Kids, it really varied. All we have at this point is anecdotal evidence. One of the things in the year following the study year, we visited all the schools just to see how the use of the online course was going in the control schools. And we made an effort to ask students whether they would have had this experience of using the online course, or would they have preferred to stay in the regular 8th grade math course. And most, not all, but most of the students said even though they did find the online course to be difficult at times, or they missed having a teacher to ask questions of, or they missed having more opportunities to really communicate and interact with their classmates, they said, I would have chosen to take in the online course because otherwise I would have been bored. So that's not systematic. We certainly need that kind of systematic information, but that's what we know at this point. And then actually, while I'm on the line, Tom Drake wrote, I've had parents say that 8th graders are too young, immature to learn in a school kind of way online. Our thoughts? Well, I think our study, and I think Jessica and Kirk will agree, our study demonstrated that certainly this population of students wasn't too immature to learn online. They did actually quite well. I'd also say that I've had, over the past couple of years, had a lot of opportunity to begin talking to, state and district leaders who are, working to develop online learning opportunities for their students. And one of the things they talk about is the fact that they believe it's going to be important for us to help, to the extent that we are moving more educational opportunities online, that we create opportunities for younger students to begin to learn the skills that are necessary in terms of learning online. Jessica just spoke really eloquently about the fact that, if we're going to ask kids or expect kids to engage in this new type of learning experience with their primary teacher being somebody who's at a distance, one of the things that everybody needs to be aware of is the fact that we are going to need to be helping these kids develop some new skills and some new ways of thinking about how to ask for help, how to maybe try to solve some more problems on their own, how to communicate with somebody at a distance. And so I would argue that they're, given the type of online learning environment that they're presented with, as well as, very importantly, what kind of support they're provided with, I would argue that 8th graders aren't too young, and I think that our study demonstrates that. Jess, do you want to add anything to what I just said?
No, I think that's great. I really agree. There's so many good questions in the participant chat. We're bouncing from one to the other, just seeing all the different questions that are there.
So Rama's question was there anything that suggested that Algebra Ready students are better prepared for online learning? we don't know for sure, and you hear two different trains of thought about this. One is that, sometimes you hear that the right kind of kid to be put into an online course is a student who is, has good, time management skills and is very proactive and responsible, et cetera, which one would think would be like an algebra ready type student. On the other hand, I've talked to other people who have watched the experiences of, for example, students taking AP courses, and they find that those students are actually really not in a great position to be in an online course because they're not used to being challenged. I wouldn't say they're not used to being challenged. They're used to having things come very easily to them, to them and for them. And this is really different, and it's really very challenging, and these students can really struggle. So I want Kirk and Jessica to add what they think, especially in light of the work they've been doing with the credit recovery students in Chicago. So I don't think we know who's good and who's really ready for online learning or not necessarily.
So
I mean,
I was going to say, Justin, Kirk, if you could answer that first question as it relates to the second study, and then the question that Peggy just posed.
Well, we don't actually have an answer to that readiness to learn online or for the second study as much, where all students had an equal chance of either taking an online or face-to-face class. We do think that there are probably that we'll probably have data to help begin to address the characteristics of students who are more likely to succeed in an online course than not, and that is of interest to us. In terms of thinking about schools, thinking about students who are good candidates for online courses, I mean, let's be fair, or let's be honest, in our Chicago study, they don't really have the opportunity to do that. All students have a 50-50 chance of being in online or face-to-face. In the virtual algebra study, the Maine and Vermont study, schools were asked to think really hard about the students that they would consider eligible for an online Algebra I course. And our conversations with them, and Peggy's alluded to this, and we did too, were mainly about academic readiness. Were mainly about readiness for the content. Some of them thought about readiness to learn independently. Some of them maybe thought about comfort with technology. But in that first year, they really thought about academic readiness. And I think in later years, which we don't have, again, systematic data on, as schools continue to offer the course, if they continue to offer the course, and if they continue to do so today, we have some suggestive, again, anecdotal evidence that they are thinking about this in different ways, and that they are learning from their experiences, and some of you on the line maybe as well, thinking about not just the academic readiness, but again, those characteristics of students that are likely to succeed online.
Yeah, and I also think that when you look at prior achievement, how a kid does the prior year in math, it isn't, an exclusive academic measure. That's the number that we have, but it also captures some of these other things where, when schools pick kids for algebra in 8th grade, they look at their test scores, but those test scores also include a lot of things, really. I mean, it's not just a single score. There probably are motivation aspects and things that are sort of part of that. I mean, we obviously can't disentangle it, but but I don't think kids' motivation and independence can be completely separated from their achievement. It's sort of all there.
Mm-hmm. I'm going to ask that you, Kirk, and then Jessica answer Lindsay's questions. There are two. I was surprised that the differences between the treatment and control groups are not significant. The lack of differences had to do with how the at-risk population is, and we may need a little more information, Lindsay, about what you mean by that. So could you give us a little bit more information about that in the credit recovery study, Kirk?
Sure. I'll start and then let Jessica fill in as well. So our theory of action really behind the credit recovery was that we knew that these kids were at risk. We knew that they had not been successful in a face-to-face course. We knew that this particular online provider had been identified by the district as one that they liked in part because there was attention to at-risk kids. The credit recovery environment sort of attracts a certain type of online teacher, and the way that they trained, Aventa actually participated in training the online mentors, so that the folks that were with the kids in the computer lab received some training by the district as well as by Aventa about some of the specific needs of at-risk kids. All of those things were going into our theory of action in terms of why this might be a different experience and potentially more beneficial. And yet at the same time, we also knew that by focusing on Algebra 1B, which is where most of the kids, where the greatest need was, we also knew that that half of the course is difficult. And I mean, those things are, you can't totally separate them. So the fact that kids did not, in either condition, do exceedingly well on the post-test, we were not completely blown away by that. So I think the answer is we tried to incorporate as many of the aspects of the intervention that would be sensitive to at-risk kids, and yet at the same time, we're all trying to figure out this stubborn thing called algebra that is in the way for a variety of reasons from a lot of kids getting where they need to be. And I'm sure that the course content, especially the second half of it, had something to do with it.
Yeah. I have a couple of theories about why we see the results that we see so far, which, as Kirk said, are really just such an early part of the story. We feel half nervous sharing them, but the lack of apparent significant differences between the face-to-face and online groups in the credit recovery study. One is what Kirk mentioned, is about engagement. So our theory is that, or hypothesis is that if students are going to be able to be more successful in an online course, it has to be because the online course grips them in a way that the face-to-face course doesn't. So it is more interactive. The content is presented in a different way. They get the immediate feedback. That those interactive features of the course really pull them in a way that the traditional face-to-face course didn't. And we haven't seen, either based on our observations or based on engagement measures on our student survey, any significant differences in engagement. So according to our theory of action, if we don't see any changes in engagement, then we shouldn't see any differences in achievement. However, we really think that this is very, very early, and that there are some other aspects of the study looking over time that we're going to be able to untangle different kinds of success in the credit recovery courses, including in the online course. Content-wise, the online course, I don't know if we've mentioned this, and and not to belabor the point, but the perception in the district is that the online course is hard, that the Aventa Algebra 1B course is difficult, the content is challenging. And so students who succeeded in the online course may have actually gotten under their belts in that summer course more content than students who succeeded in the face-to-face courses. We just don't know that yet. And we really will have the opportunity to continue to follow these students. This is a 4-year study, so we'll follow them through expected graduation all the way through high school to see what happens over time. I think it's a great question that you posed, Lindsay, and we're going to keep studying it.
And some of that information that will also be available later will be things like the topics that teachers covered in the face-to-face class, as well as their grading systems. With an online course, it's right there for you. You know what the chapters are, you know how far the kids got, you know what they got on their quizzes. And I think some of that information also later, when that's available, will be helpful in framing the context of both environments.
Mm-hmm. Thanks, Kirk and Jessica. We also did pose a few additional questions about cross-cutting themes that emerged from the two studies. Are there some things that you noticed as being commonalities across these two studies? And I'll turn this question first over to you, Kirk and Jessica, in that you have been involved in both of them. Are there some bigger ideas that have not yet been talked about?
You know, I think we have touched on most of them. I mean, we're sort of trying to figure out how to help kids succeed, get access to and succeed in algebra from all different angles. And by looking at 8th and 9th grade kids, at higher achieving, potentially more highly motivated kids versus kids that were not successful. You know, I think that's sort of a cross-cutting theme. And we also just don't know that much about online courses in a rigorous way. We're also learning a lot, not just about their impact, their effectiveness, but also what it means to implement a specific online course in terms of what the teachers do, what the proctors do, and so forth. So I think those are kind of the common themes and where we're trying to build better evidence. We're certainly not to the point where we've done a study that looks at the Khan Academy combined with a smart board. I mean, there's so many variants because things are being introduced. Seems like every week you hear about a new website or something that is, you know, out to help kids. And again, even just thinking in math, which is my area of expertise. So I think what this will do, hopefully, these two studies is kind of provide a foundation for answering some of the impact questions, and then maybe looking forward to some of these other implementation questions, how things might be implemented in particular ways. Are there certain ways that are more promising than others, and as these new technologies come out?
Yeah. No, I really agree. I just, you know, just wanted to add that both of these studies provide kind of a wealth of opportunity as far as the data collected. We have pretty rich data on both studies. And to address some similar issues in these very different contexts, in these mostly small rural schools and these mostly big urban schools, online courses being used for very different reasons. Content of the course is very similar. Providers are different. Proctors and mentors, you know, we have a lot of implementation data. I think that I think we've covered a lot in this session on the cross-cutting themes on the studies that we have, both, you know, as reported in the official report on the online access to online algebra study, and, you know, unofficially shared with you guys today from the credit recovery study. But just to let you know, what we'll have in the future, especially with the access to online algebra study, fingers crossed, are actually public restricted use data sets that will be available to researchers that include all of our data. So people ask questions about, did we disaggregate data by usage level? Did we collect data from students about what they thought about their courses? The answers to those questions are, in some cases, are no, not yet. And we will, and others will, other researchers who weren't part of conducting the study will have access to data, including student survey data about how they felt about their courses and the online course and the proctor data that we talked about. And so we have the cross-cutting themes as they are to date, and we have much longer-term cross-cutting themes to come. And, you know, again, we look forward to working through the Alliance to do some of that work and to really build what we know about, you know, the best conditions under which we can implement online courses.
Thanks, Jess. Peggy, I want to ask you this next question. What policy issues are related to students earning online credits? One of the policy issues that I'm very aware of as it related to some of these things begins to look at teacher qualifications. If you have certain teacher certification issues in one state where the course provider is located, and you have another set of certification requirements and the receiving state, we start to have some policy issues begin to arise there. Are there other policy issues that you think are beginning to surface as we start to look at these types of offerings?
Pam, that's a really good question and a really good point. I mean, we've been talking about, you know, kids' educational and instructional experiences and outcomes, and I think, you know, at least for me personally, that is what I find most important and interesting. But in many settings, when I'm talking to educators and district leaders, these kinds of issues about teacher evaluation processes, teacher certification, teacher qualifications, the implications for what that means to face-to-face teachers. Those are really big issues, and I think people are still working to figure them out. There's probably some states that have longer histories of like Florida, possibly Michigan, of having large online learning schools where maybe they've started to figure some of this out. But I think for many, many places, these continue to be thorny issues that we don't have solutions for. Another policy issue that at least I'm starting to think about a lot is the fact that when kids are enrolled in online courses, probably not so much in the Chicago study, because that study took place in the context of the school system, but I don't know. But definitely for something like the online algebra study, you have a situation where kids are enrolled in an online program. In this case, they were enrolled in the class.com online algebra course. But it's the schools that are the grade granting institution. And so I know we're encountering in a number of states where whether a student even took a course as an online course may not be recorded in their student record. And so it makes it difficult for us to, for the online course providers then to know, well, what grades are students being assigned, and what are the implications of that. And it will be difficult for people people at the district level, for example, to look back and even see, well, which of our students took online courses and why, and under what circumstances, et cetera. So there are a lot of important logistical and these other types of policy issues that I think we need to do a lot of work on in terms of finding solutions for them, because they're really important, especially given how rapidly online learning is growing. Jessica, do you have anything, and Kirk, do you all have anything to add to that?
No, I think you did a great job. I just wanted to say we have that exact problem that we've seen that exact problem that you just raised in our Chicago study, where records from the district don't actually, we know who our student participants are, and we know exactly whether they took an online course or face-to-face course, but that's just because they're study records. We would and be addressed.
Thanks, Jessica. We have about 2 more minutes, so I want to say that the third question here is really important to us as we move forward in this 5 years of work within this alliance, and for you and your role in the state, district, or school is really important. So we encourage you to enter any ideas or concerns that you have, as we're constantly trying to elicit what's going on, what you see are needs, what are the most important research questions for us to be asking as we do our work over the next 5 years. I did want to make sure that you were aware of the resources. Peter Orn in the warm-up actually talked about the new REL website at relne.org. You can find links and more information about the alliances, including this one. You can also link to the Doing What Works website, the What Works Clearinghouse, where we have the practice guides available to folks, and so on. And lastly, I just want to make sure that you are aware that you can download these studies. There have been links posted in the chat, and it's really important to us that you contact us if you want additional information, as well as how to get to any of these resources. Additionally, there is going to be an archive posted online on the relne.org site, and it's very important to us as well that you take the survey. The link has been posted in the pod below this, as well as you will be linked to the survey as soon as we finish this webinar momentarily. So please take the survey. The feedback is very useful to us, And we thank you very much for participating. I want to thank all of the different staff on this webinar. Thanks for all the technical folks in the background and our researchers. Thank you, Jessica, Peggy, and Kirk, and everyone else involved. So thanks again, and please feel free to contact us. I'm the liaison for the Northern Tier states, Maine, New Hampshire, and Vermont, and I notice many of you are from those states. And also, if you are interested in the needs of rural schools, please let us know, and we'll continue to stay in touch. Thank you very much.
Thank you.
Thank you, everyone.